In this recording, we are going to explain completing the square of a quadratic where the value of a is greater than 1. We all know the value of a is the coefficient of x squared, right? Now, it says completing the square when a is greater than 1 has several more added steps than what we previously studied. The main point is that you can only open that curved bracket followed by x, that is a curved bracket, x plus, only if a is equal to 1, right? So when you are completing the square, you have to open a bracket and you put x and plus or minus, and then you put your p close bracket squared. But the rule is that you can only open the bracket when a is equal to 1. In the examples we did, when a is equal to 1, we open the bracket right away. That is in slide 75. Now it continues to say the following are some brief steps that can be followed to do such an operation where the value of a is more than 1. After you have perfected the skill, you can skip several of these steps to save time. So let's check out the steps. Steps to convert ax squared plus bx plus c with a greater than 1 to a outside of x plus p all squared plus q. So the first thing you do, you identify a, b, and c. Then you are going to use square brackets to factor out a from ax squared plus bx plus c. How do you do that? Here it is. You put a outside of a square bracket, you open a square bracket, and all the three terms of ax squared plus bx plus c, you're going to divide by that same a. So please bear that in mind. You open a bracket, you put a outside that square bracket, and then you put ax squared over a plus bx over a plus c over a, and you close that square bracket. So that's how you factor out a. And what's going to happen is now that a will be outside of the square bracket. Inside of the bracket now, you're going to have 1x squared because a divided by a is 1. And that's what you want to achieve. You want a 1 in front of x squared for you to open that curved bracket. And then the remaining two terms, you have bx over a plus c over a. But in front of the x squared, the a has been cancelled out, and here it is outside of the square bracket. So now what you are going to do now, since the value of a is 1 inside of the square bracket, you can go ahead in step number 3 and complete the square of this quadratic in the square brackets where a is equal to 1. You can do that inside or outside the square bracket because what you have now is a quadratic where a is 1 inside the square bracket. Now after you have done that completing the square, remember the steps that we followed in slide 75, you multiply by a to clear out the square brackets because remember completing the square have a curved bracket. Anytime you complete the square, your answer must have a curved bracket with a outside of the first bracket, the opening bracket. So now you'd have two brackets, a square and a curve, and the curve will be inside. So you want to get rid of the square, so you multiply by a. The first multiplication will put a in front of the curved bracket, and the second multiplication will give you the value of q. And then simplify the new value that you are going to receive. So here you have an example. Transform 2x squared plus 12x plus 7 to a open bracket x plus b all squared plus q. So to make the video interactive, I would like you to take out a pencil to start doing it. So here we are going to explain this example. Here we have 2x squared plus 12x plus 7. As you can see, it is in the form ax squared plus bx plus c, where a is 2, b is 12, and c is 7. And we want to transform it for it to look differently, for it to look like a open bracket x plus b all squared plus q. So a means 2 have to be outside of the open bracket in your final answer. Now remember the steps. Let's go a little bit above to have the whole window at view. First, we have to identify A, B, and C. So here we are. A is equal to 2, B is equal to 12, C is equal to 7. Now, the second step is to use square brackets to factor out A from ax squared plus bx plus c. And how are we to do that? Put A outside of a square bracket, and inside of the square bracket now we have ax squared over A, bx over A plus c over A, and we close the square bracket. And then we divide out A, so I left with x squared plus bx over A plus c over A, close bracket, with A outside of the square bracket. So let's do that here. Here it is. A is 2, so you put 2 and you open a square bracket. And inside of the square bracket now, you write down 2x squared plus 12x plus 7, but beneath each one of them, you put divide by 2, because A is 2. You see, just like how we have ax squared over A, 2x squared over 2. Bx over A, 12x over 2. C over A, 7 over 2. Okay? And then you simplify. 2 divided by 2 is 1, and that's what you want to achieve. You want a 1 in front of x squared. So you have 2, that is the A, outside of the square bracket, and inside you have x squared plus 6x, because 12 divided by 2 is 6, plus 7 over 2. It remains as 7 over 2 because 7 is an odd number, so you leave it as an improper fraction. Now, the third step says to complete the square of the new quadratic that is in the bracket. Okay, the value of A is 1 now, so we can open a curved bracket. Remember, completing the square requires a curved bracket. So you open a curved bracket. Now the curved bracket can be opened because A is 1 inside of the square bracket. So you open a curved bracket. You don't write x squared, you write x plus, to get P now, is 6 over 2. Always divide by 2. So you divide 6 by 2, and you close the curved bracket, and the square you put it outside of the curved bracket. Okay? Close bracket, squared. And then now, to find the value of Q, you have to minus the square of P. P is actually 6 over 2. P is 3, but you leave it as 6 over 2 because you have a 7 over 2 to deal with. So it's subtract 6 over 2, close bracket, all squared, plus 7 over 2. Okay? That step is very important. To find the value of Q, you have to minus the square of P. P is 6 over 2. Okay? You can have 7 over 2 minus 6 over 2 squared. Or you can have minus 6 over 2 squared plus 7 over 2. But you always have a minus 6 over 2 squared. Anytime you close the square bracket and you put the square above there, you have to minus P squared. And plus the value of C. C was 7 over 2 now. Then you work this out. 6 over 2 squared. That will give us 9. Because 6 over 2 is 3. 3 is a 9. So that's why you have a minus 9 there. And then you got a minus 9 plus 7 over 2. Here we have our 3 because 6 over 2 is 3. And we have to work out what is minus 9 plus 7 over 2. This is minus 7 over 11. This is fraction, so please work out what is minus 9 over 1 plus 7 over 2. It's also get minus 11 over 2. Now, the fourth step now is to multiply by A to clear out the square bracket. So we don't want our answer to have a square and a curve. It's only a curve with A outside. So we have to multiply by 2. It will multiply to the curve bracket, the first curve bracket, and that 2 will also multiply to minus 11 over 2. So the 2 times the curve bracket will appear in front of the curve bracket. Here it is. And 2 times minus 11 over 2, the 2's will cancel out, and you're left with minus 11. And here's the final answer, 2 outside of x plus 3 all squared minus 11. Now, as you can see, it is looking exactly like this. A outside of x plus p all squared plus q. So the square has been completed.